not 25. So that means here, you need to divide by 50 over 1,000. Then you find your OH minus concentration. I will leave the calculation for you because this is the most critical. After you find the OH minus concentration, are we able to determine the POH value, which is negative log of your OH minus right from top? Of course. Can you find the pH value? Yes, 40 minus POH. This is the key pointer. Now, before I transit to the buffer part, do you have any questions about your basics of calculation? This is very, very important actually. I give you a couple of seconds for those of you who have questions, you can type in the group chat. Someone should ask me, do we use method 1? Do we need to indicate the exact pH on the graph? The answer is you do not need to indicate the exact pH on the graph. You do not need to. You can write greater than 7 is fine, but I understand that some schools actually prefer to find the exact pH, so I show the second method. One student asked me, the total volume is 50 and not 55. 55 is the final one. This is equivalence point. Equivalence point, you just add in exactly 25 cubic cm of NaOH and 25 cubic cm of acid. Total is 50, not 55. 55 is the ending. Equivalence neutralization is 50. So one question asked me is, do I need to take the total volume? Answer no. Total volume is the end. Neutralization, take a look again. You just need 25, 25. You never add more than that. Remember, this is a titration question. This is a titration. You can control the volume. You know that pour one shot, you can control the volume. So at a specific point, only 25. So next question, do we not use buffer formula? We are using buffer formula. If you realize, we are using ice table. This is a neutralization reaction. I don't see any question coming. So remember, 1 or 2, perfectly fine. But I know there's a number of schools prefer this method. There's a reason for that, because this method will help your logic even better. But in A level, you are allowed to write this. So later in the presentation, I'll be using number 1. But number 2, I show it to you already. All you need is press calculator. Now let's move on to step 3. Step 3 is buffer. Now this is not a normal buffer. This is a maximum buffer capacity. Maximum buffer capacity. Yeah? So there are 2 different types of buffer that can exist. One is weak acid at a strong base. The other one is strong base at a weak acid. I know that my weak acid is in the conical flask. So this is a strong base add in. Strong base add in, what do I use? Well, I can use pH equals to pKa. Now, some of you ask me, why is it pH equals to pKa? Let me explain to you. Because pH equals to pKa plus logarithm salt over acid. This is a typical acidic buffer equation. Acidic buffer Henderson-Heisenberg equation. In order for maximum buffer capacity to take place, your salt and your acid must be exactly same concentration. I said before that maximum buffer capacity only take place if your salt and your acid same quantity. Same quantity means same concentration. What will happen if they have the same concentration? Logarithm 1. Logarithm 1 is 0. So pH equals to pKa. So I just go straight to the point. Negative log 10 to the power of minus 4.6. Answer 4.6. pH equals to pKa. Second, this is the weak acid in the conical flask. You add something strong in. So the y-axis, which is the volume will be equals to halfway the equivalence point. Your equivalence point is 25, halfway through 12.5. So this is the two key value. After that, step 4. Remember, I eat banana is every day. Every day here is your ending point. Now that will depends on who is adding SS. So who is adding SS here? I think 30 cubic is SS, right? So what I will do is I need to find the SS volume. So the SS volume here is your NaOH. So what I need is I take 30 minus away 25, I get 5 cubic cm. 5 cubic cm of the SS. So what I will do is I need to find a new concentration. Let me just draw a diagram for you to see. Initially, you have 25 cubic cm of your ethanoic acid. Now you're going to dump in 30 cubic cm of your NaOH. 30. Total volume, 55. This is the ending point. So that means when you calculate the new concentration of your NaOH, you need to factor in the final volume. So I take 5 over 1000 times 0.1. This will tell me the moles of your NaOH, that is the excess amount. This is only the moles. But it's not sufficient. I need to divide it by the total volume. Total volume is how much? 55. Then from here, I can find the concentration. So the concentration here, just give me a second. If you know this is a strong base, can you find a POH? Definitely. POH is equals to negative log 0.00909. Then you will get a value, then followed by pH equals to 14 minus POH. This will be about 12. So which means that I have 12 as the final pH value. At the same time, what is the total volume I use? 30 cubic cm, right? Because I'm only interested in my NaOH. This is I eat banana every day. Now I know this looks very draining, very tedious, but as long as you remember my acronym and the technique, you know how to solve all titration graph. So let me just show you how I'm going to draw it right now using I eat.